Sure, here's a detailed, simple, and comprehensive explanation of each topic you requested from a full Python course, organized clearly to help you understand everything step by step. Python full course topics, complete explanation in simple English. 1. Knowing the computer. Before you start programming, you should know the basics of how a computer works. Hardware. Physical parts like CPU, brain, RAM, short-term memory, hard drive, long-term memory, input-output devices, keyboard, screen. Software. Programs and operating system, Windows, Mac OS, Linux that make hardware usable. Computers run programs, software, which are sets of instructions telling the hardware what to do. 2. What is Python? Python is a programming language. It's easy to read and write, making it great for beginners. High level. Close to human language, easy to understand. Interpreted. Python code runs directly without needing to compile first. Dynamic typing. You don't need to declare variable types explicitly. Used in web development, automation, data science, AI, and more. 3. Installation. To use Python, you must install it on your computer. Download from python.org. Install by following the setup instructions for your OS, Windows, Mac, Linux. Set up the system path so you can run Python from the terminal or command prompt. Optionally install an editor or IDE integrated development environment, like VS Code, PyCharm, or use the built-in IDLE. 4. Flowcharts and Algorithms. Algorithms are step-by-step instructions to solve a problem. Flowcharts are pictures showing these steps visually. Flowchart symbols: oval, start, end, rectangle, process step, diamond, decision, yes, no, parallelogram, input, output. Before coding, write an algorithm or draw a flowchart to plan your solution. Example: algorithm for adding two numbers, get numbers, add them, show result. 5. Python Introduction. Basic concepts to start programming. Python code is written in scripts or run interactively. Variables store values, numbers, text. Data types include integers, floats, decimals, strings, text, and booleans, true, false. Use print to display output. Comments, hash, explain code and are ignored when running. Example program: print hello, world. 6. Input and output. Communicate with the user using input and output. Use input to get data from the user. Input is always text. Convert input to numbers using int or float if needed. Use print to show results. Format output using f strings. Name equals input, enter your name. Print f, hello, name. 7. Problem solving. Steps to solve programming problems. Understand the problem carefully. Break it down into smaller, manageable steps. Plan the solution using algorithms or flowcharts. Write code and test often. Debug by reading error messages and checking your logic. 8. Decision making. Use conditional statements to make choices in your code. If tests a condition and runs code if true. Else if tests additional conditions. Else runs if all previous conditions fail. Example: age equals int, input, enter your age. If age greater than equals 18. Print you can vote. Else, print you are too young to vote. 9. Strings. Strings are text stored in quotes. You can manipulate them. Access characters by index, starting at O. Slice substrings with start, end. Common methods: lower, upper, strip, split. Join strings with plus or join. Example: text equals hello, world. Print text 0, hash h. Print text lower, hash hello, world. 10. Loops. Loops repeat code multiple times. For loop, iterate over sequences like lists or ranges. While loop, repeat as long as a condition is true. Control flow commands. Break stops the loop early. Continue skips the current iteration. Example: for I in range 5. Print I. 11. Functions. Functions group reusable code, defined with def keyword, accept parameters, inputs, return values with return, help organize and simplify code. Example: def add a, b, return a plus b, print add 2, 3, number 5. 12. Lists. Lists hold ordered collections of items, created with square brackets. 1, 2, 3. Items can be changed, added, or removed. Methods: append, remove, pop, sort. Can hold different data types in nested lists. Example: fruits equals apple, banana, cherry. Fruits. Append orange. Print fruits. 13. Tuple. Tuples are like lists but immutable, cannot be changed. Created with parentheses. 1, 2, 3. Used for fixed collections. Support unpacking. A, B equals 1, 2. 14. Sets. Sets are collections of unique items, unordered. Created with curly braces. 1, 2, 3, or set. Useful for removing duplicates. Support operations like union, intersection, and difference. Example, A equals 1, 2, 3. B equals 3, 4, 5. Print A and B number 3. 15. Dictionary. Dictionaries store key value pairs. Created with curly braces. Name, Alice, age, 25. Access, add, or change values by key. Methods, keys, values, items. Example, person equals name, Bob, age, 30. Print person name, hash Bob. Person age, equals 31. 16. Problems based on list, tuple, sets, dictionary. Practice combining data types to solve problems. Count frequency of items using dictionary. Find unique elements with sets. Use lists to store and manipulate sequences. Return multiple values using tuples. Example problem, count how many times each word appears in a sentence using a dictionary. If you want, I can provide example programs and exercises for any or all these topics to practice. Just ask, would you like that?